In a follow-up to a video that I put out about a week ago, I wanted to show a program that I wrote where you can generate G-code for your printer to print the same types of curves that I showed in this last video. So even if you haven't watched the last video, we'll just jump right in and we can look at the tool. The program runs in the browser and I'll put a link to it. But basically we have a 3D preview of what will get printed, and by default you can change this little drawing, which are smooth Catmull ROM splines, and you can double click to add points, and you can switch to straight lines. And then where things get interesting is if we start changing a rotation curve, each layer gets a rotation and a scale applied to it based on where it is along the curve. So you can see about the middle layer will end up somewhere here, like 75 degrees rotated of this original curve, and a scale can be applied too. Now, this shape is not very good for 3D printing because if we zoom in and imagine a extrusion path, those layers might not overlap and we'll get the same type of striations that I pointed out in the last video. So to fix this, you can enable a clamp distance, which just ensures that the point that gets moved from here into the next layer is no more than this amount away. And you can see that the preview here are actually just wireframe lines, and you can enable a real 3D preview, but it's much slower and I don't have it tuned very well, so it looks a bit wonky. But if we do much more than 100 layers, then this process gets really slow. So, and then to aid in the 3D visualization, I'm just applying a rainbow by either the distance to the center of the z-axis or by a layer so that you can have a better visualization of the 3D from these super thin lines. If you turn this off and just use a 3D, it can get a bit hard to see. So I find this a lot easier to visualize. So you can really just play around, double clicking to add points. You can remove points with right click. We can maybe open this up like a real vase. Oh, that didn't. There we go. And then if we are happy with the shape that's generated and we want to print it, you can scroll down and configure some basic printing parameters and then hit generate G-code, which will take this G-code header and then insert the generated points and then insert this G-code footer. So you can change this based on your printer. This particular header and footer is taken from a print generated by Cura for an Ender 3, which I think it should be pretty similar to most printers. And there's just a couple of substitutions that happen here for bed temperature and hot end temperature coming from up here. And so if you click on this link, you'll download the G-code file, or you should be able to open it in a new tab to just view it directly. So you can see we have that header, and then here's all the generated points, and it goes on like that forever. And then the footer. There's some documentation down here that is probably confusing, but that's about. So then one more thing you can see here is that we have an option to upload an SVG and use that curve. So by default, it'll just load in this sample file that I've included. That is the same curve that you see on all of these test prints. And so if you don't like this, well, so right now I don't have any in-browser SVG editing because there are much better programs to do that. So I'll just show how you might do that with Inkscape. So here I just have a new document from Inkscape. One thing that's helpful is to change your document properties to your print bed size so that we know what things are going to look like. And then, for example, we can use the pen tool with some smoothing and kind of just draw whatever shape we want. And even though if these points don't intersect directly, we can either snap them there, or the code will insert a connecting line for shapes that don't match. And we can just use the position as a size reference and go ahead and draw another curve. Maybe we'll do this one with the spiropaths, which are kind of fun. They give you very kind of arcs. And you can close this off. And now, once we've drawn our two paths, we can save this and upload it. When it doesn't upload anywhere, this is all just running in the browser. And there's our first path, and I think these are actually flipped about the x-axis. That's maybe something I should fix. And if you have more than one path, you can toggle between them. And so let's maybe try and get some more rotation on this. And then we'll bump up the layers. And this isn't like the fastest thing in the world. So just be patient if you're gonna do a lot. So yeah, that's looking pretty cool now. Oh, and you can see that the other thing is even though these paths were not centered wherever they were, it will auto-center based on the median point, which is the same point actually that the rotations occur about and the scaling occurs about. Right now these bounds are not configurable, but this would obviously be a good thing to do. But in some ways it's not that useful, because when you have clamping enabled, you can't end up with too much of a rotation unless your print is really tall. Alright, so I guess I'm going to try and print this whole thing. We can see that it's about 220 by 220 by 100 millimeters, and this gives you the positional bounds. And yeah, I might change this line width down to 0.3, because, disclaimer, I'm not sure if the calculations I'm doing are exactly the same as a regular slicer would. And the couple test prints I've done have come out a little bit thick. So if you look through the source code and notice an improvement, make sure to send a pull request and I'll get that merged. So we'll go ahead and generate the G-code. I should probably add a way to ensure that we know that it's done. Alright, so I will get that printing and insert a little time lapse. So I guess I wasn't paying super close attention because this turned out much bigger than I thought. And two things to notice are that I should have left either the clamp distance, I should have decreased that when I decreased the line width, or just have left the line width at 0.4. Some of these layers didn't bond super well. You can see it's kind of cracked there. And then here we have the same issue of the striations that where the layer wasn't bonding, and so it cuts through like that. It is kind of a cool effect where the layers don't bond super well, because you get this kind of ripple effect. And then over here you can see that it's actually flat, and actually looking back at the bounding box, it was too big for the print bed, so the printer just clamped that off itself and ended up with this flat spot. But overall, I think it was cool. I think this took about 3 hours to print, and yeah. So that's the kind of thing that you can make with the tool as it is. If you make something and print, I'd love to see a picture of it. And if you have any ideas on improvements to the tool or things that would make it better, let me know in the comments below.